All right, guys, welcome back. So we're going to look at some more proofs. And our objectives today are writing proofs with geometric concepts and with different algebraic scenarios, right? So I already did proofs with equations like x plus 4 equals 2, right? 5x minus 4 equals 10, right? X over 4 plus 5 equals 6. So we already did proofs with those, okay? Then in Algebra 1, we solved an equation that only had mostly variables or letters. So we're going to do those the same way, okay? When you deposit money in the bank, you gain interest. So there's something called simple interest. Most people have compound interest. We can't use that example because the math is too complicated. But suffice it to say, when you put your money in a bank, they pay you to put your money in the bank. That's because they invest it and make money off of your money. So everyone makes money. Okay. So they use a formula, and I apologize here because I didn't save this as a PDF. Formula is I equals PRT. I is the interest, P is the starting amount, R is the interest rate, and T is the time. So now we want to solve the formula for R and justify each step, which means we want to write a proof. So I'm given I equals PRT, and I'm trying to prove that R equals something, which I don't know what it is yet, but I'm trying to find R. So I have my statements, I have my reasons, okay? So in my statements, I equals PRT, reason is given, okay? Now I'm going to say RT equals RT because I know I need to divide RT out to solve for, PT. I need to get R by itself. So I have to make PT equal to PT. I'm going to divide both sides by PT. Okay, that's the division POE. Okay. Then I get I over PT equals R. And that's substitution. So once we've solved for our variable, and actually, let's put the R on the left-hand side as we have it in the proof statement. Okay, and that would be symmetric. So just know that, sometimes you may not get a given and approve, but you'll have to write those out, okay? So we're just doing the same thing that we did with variables, okay? Not just numbers, but you can do the same thing. It works the same. Reflexive, operation, substitution. Usually follows that pattern, remember? Okay. All right, next one's area of a triangle. So the formula for the area of a triangle is 1/2 base times height. Excuse me. So we want to solve for the height and justify each step. So again, what we're given in these is a formula, okay? What we're trying to prove, let me write these out. Okay, what we're trying to prove is that the height equals something. Again, we don't know, but we're going to fill that in once we're done solving, okay? So sometimes they don't tell you what you have to prove, but you have to show, solve for what you need to solve for and show that you prove that the variable h in this case equals some quantity, okay? So we're going to start off again with the 1/2 base times height. That's given. I need to solve for height, so I'm going to get rid of that 1/2. So I'm going to say 2 equals 2. Reflexive. POE. Okay. Multiply 2 on both sides. Okay, that's multiplication. POE. Okay. We have substitution, clean it up. Now I have to get rid of that b. So I'm going to say b equals b. Reflexive. Okay. Divide both sides by b. Okay. That's division. Okay. And then we get 2a over b equals h. That's substitution. And again, I'm just going to flip it around. So let's make sure we have for these problems, let's make sure we have the letter that we're solving for on the left-hand side. Okay? So h equals 2a over b. Okay? So again, we can solve for equations that have more variables than numbers, right? But they work the same way. Okay? Same as up here. Sorry, it's all jumbled up. I'm using Microsoft Word, then forgot to put it in the PDF. Okay. All right, so we now want to add our geometry knowledge into proofs, okay? And we're going to look at segment addition postulate and angle addition postulate, okay? So remember, segment addition postulate said that the sum, okay, the measure of a line segment is equal to the sum of its parts, okay? So you can break up a big line segment. That'll equal the smaller line segments. The angle addition postulate is basically the same thing for angles, right? A bunch of smaller angles, right? If they're adjacent, their measures can add up to equal the sum of the entire angle, right? And we did this previously. Okay, so let's look at example 4, which is very goofed up here, but so we've got this picture. So now we're going to be given pictures in our proofs. Okay, so that's a new one. Okay, so now we're going to try and prove that x equals 8. Okay. So now we're not given an equation, so we have to make an equation. Okay. So we're given a figure. Actually, you don't have to write the figure. It's fine. AB equals 2x. BC equals 24. AC equals 5x. That's given. Now, you need an equation for all this stuff. So, to make an equation to solve for x, we need to use the segment addition postulate. So we're going to say AB plus BC equals AC from the figure, right? This is the segment addition postulate, SAP, okay? Okay, now we need to take this equation that we wrote and we need to plug in, okay? So we say 2x plus 24 equals 5x since we plugged in everything that we had, right? We replaced. So that would be substitution. Okay. Now we just need to solve 2x equals 2x. That's reflexive. Okay. Then we're going to subtract from both sides. Okay, get rid of that 2x on the left. So we get 24 equals 3x. Okay. Oops. I'll put substitution there. I should say subtraction. Okay. All right, so now we need to solve. 3 equals 3. Okay. I'm going to write out all the steps first. You can do it this way if you want. You could write out the steps and then put the reasons if you want. But again, this is the same as we did last class, right? So you need reflexive to introduce something that you're doing, adding before you add, subtract, multiply, and divide. Then you actually do the operation, substitute, which basically means simplify, but we don't use the word simplify here. And if necessary, flip it around using the symmetric property. But the whole goal of this problem was we need to use segment addition postulate so that we can find an equation to solve, okay? That's our goal. So you have to have the segment addition postulate to even find an equation, because I didn't give you an equation to solve for x. So now you have to use the geometry to solve, find the equation, okay? All right, last one. So we've got prove 8 equals x. All right, so the next one's going to work the same way. We've got an angle, so now we have to use angle addition postulate. Okay. Because again, we're given some stuff here, but we don't have an equation, so we can't solve for x unless we make our own equation. And we make our own equation by using the segment addition postulate. Now, for the sake of time, I'm going to put this in here and put given, okay? Yes, you have to write them out, okay? So I just don't want to bog you down with the... Anyways, so in the second statement, I'm going to say that the measure of angle KLB plus the measure of angle MLB, or I should say BLK.
Pardon the interruption. For the following announcements. All of Mr. Bianik's classes except C period should report to the library. C period reports to class as scheduled. All of Mr. Shear's classes, including his homeroom, should report to the library today. Mr. Schulteis's D period only should report to the library today. All of Ms. Coyne's classes should report to the Smith Center today for class. And finally, all of Mrs. Cruz's classes and her homeroom should report to the Smith Center today for class.
Okay, sorry for that announcement. So again, I use the angle addition postulate here so that I can have an equation, right? So I take the angles, I write them, I make an equation for them so that I can solve for x, okay? So again, we're using the postulates, okay, to come up with some geometric equations so we can plug in the algebra later, okay? So really, you set up the postulate and then you substitute in the values, okay? That's usually how it goes. And then here I combine like terms while the announcements were going on. Okay, combine like terms, it's substitution, right? Instead of 2x plus 4x, I substituted 6x. Step 5, 40 equals 40. Okay, so I'm going to subtract that 40 eventually, so I need to introduce it as equal to itself. And I'm going to subtract it from both sides. All right, so the subtraction. Then I get 6x equals 48. That's substitution. Now I'm guessing you can finish the rest. Okay, 6 equals 6. Divide both sides. X equals 8. And again, all right, so reflexive. Division. Substitution. Symmetric. Okay. So again, the overall point of today is that we can, number one, use letters, okay, in an equation and still do a proof, okay? We can use the angle addition postulate to come up with an equation and then substitute algebraic expressions so that we can solve a proof that deals with a little bit of geometry. And we can do that the same with the segment addition postulate, where we set up an equation and then again plug in algebraic expressions and solve. Okay, so that's our goal. Okay. All right, so I will talk to you guys tomorrow.